We are again going to try to find increasing and decreasing intervals for this function, and we have a restriction on this one since the x values could not be less than -4 or more than +4. You can see that would give you square root of a negative number, so that's outside of our domain. And this is similar to the last couple, except this one is going to be a little tougher algebraically. So I went ahead and wrote the square root as an exponent of 1/2. And now I'll go ahead and do the derivative. Since I'm going to be finding the critical numbers, I need to know where the derivative equals 0. And to do that, I've got to have the derivative, of course. So looks like I've got product rule here. So I could take the derivative of this while I leave this alone, plus the derivative of this while I leave this alone. So if I bring the power down, that would put a 1/2. If I lower the power by 1, that makes it be a square root in the denominator. And then I've got to worry about the chain rule here. The derivative of the inside would be -2x. Okay, so before I even begin to try to clean this up, or figure out where it equals 0, I want to try to clean some of this up. So get the square root of 16 minus x squared minus 2x squared over 2 square root of 16 minus x squared. Okay, and we can see that the 2's are going to cancel, so I'm just going to go ahead and erase those. And I'm going to force these two terms together with a common denominator. So if I multiply this one by the square root of 16 minus x squared, I need to multiply this one by the square root of 16 minus x squared. And luckily, the square root of 16 minus x squared times the square root of 16 minus x squared is just going to be 16 minus x squared. Okay, so with that progress, I've got 16 minus x squared over my now common denominator. And these are like terms, so I can go ahead and combine those together as well. Okay, so it's not real pretty, but here is my derivative, and now I can start thinking about where this equals 0 for my critical numbers. Now I also have to be concerned what is undefined. It looks like the denominator would be 0 at 4 and -4, but remember, based on our domain here, that's at the endpoints of the domain anyway. So to say that it's increasing before -4 or increasing or decreasing after +4 doesn't really apply here because we're only interested between these two values. So for that matter, I'm really only interested when the numerator equals 0. So I don't know, we could factor out a -2. And then I could set this numerator equal to 0, and I could divide both sides by -2, which is like ignoring it. Could add 8 to both sides, and finally take the square root. And of course, when you take the square root of both sides, we need to consider plus and minus. And the square root of 8 is not a perfect square, but it does reduce to 2 square root of 2. Okay, so all of that work to find the derivative so that I could set it equal to 0 to find the critical numbers. And now I know which numbers it is likely to be switching from increasing to decreasing or decreasing to increasing. And it's at those two locations, but there's no guarantee. So I need to try to find some values between those and figure out if it's going up or down there by testing if the first derivative is positive or negative. Maybe a number out here like 4, and maybe a number to the left of that one like -4. Alright, so if I slide back up and look at the derivative, So I can't, I guess I picked 4 and -4 here, but remember, if I plug in 4, that's going to give me division by 0, so that's going to be undefined. So that's actually a little bit too far. Maybe I'll switch this to 3 and -3. Okay, so if I'm trying to think of the derivative when x is 3, let's plug that in and see what happens. Looks like we get -2 over 1, but the important thing is that that would be negative. So if this has a negative derivative, I know the slope is going down. I could try to plug in 0. So that would change this guy and this guy. And so that would give me 16 over 4, which would be 4, but more importantly, it's a positive 4. So the derivative at 0 is positive, so I know the graph is going up there. And then I could try a point to the left of this critical number, like -3, which would make, remember, -3 times -3 is positive 9. -3 times -3 is positive 9. Be careful to square all of -3 and not just the 3. And now this looks like this one. So I get -2 on top, positive 1 on bottom, so that would be -2. More importantly, it is negative. Therefore, the function is going down at that value. And now I can visualize my increasing and decreasing segments. Looks like it is increasing just between these two x values. And it's decreasing in 2 locations. From -4, because remember -4 is the far left of our domain here, so not negative infinity this time. -4 to this critical number, and I guess with increasing and decreasing though, I just tend to always use parentheses here. And then it's decreasing here as well. So from this critical number to the far right, and the far right for this question is +4. So in the end, these are increasing and decreasing segments.